All right, I thought I'd just do one more example for you dealing with the quadratic inequalities. Why? Because I want to. No other reason, just I thought for some people it would be nice to see one more example. All right, keep in mind that if you have a problem with solving quadratics, then that information is in the intercepts unit on the website. So you can go back and you can look at factoring and that kind of thing if you need to, or you can look back at the quadratic formula. If you want to look at transformations, that would be in the transformations unit. So you have lots of other resources. However, I'm not going through the specifics of factoring, graphing, quadratics, all that kind of stuff now, because at this point, this is now our third time seeing graphing quadratics. You should be fairly comfortable with most of those things. All right, so like I say, if you need practice with that, go back to the unit on intercepts, look at the website, and try to work with it from there. Or just come in and see me. That's fine too. All right, so at this point, let's go ahead and deal with the inequality. Now remember, what we're going to do is we're going to graph the equation. Okay, assume for a minute that it's an equal sign and graph it. Then we're going to decide whether it's a solid or dashed based off of the inequality. Then we're going to test a point and shade it. Exactly the same as what we did in the last video and what we did with the linears for that matter. All right, so here we go. We're just going to assume at the beginning y equals -2 times x minus 1 squared minus 2. Now I'm actually going to work through this in two ways because I want you to make a choice of the easiest or the best way to do it. So the first way is I'm just going to straight up work with it. I'm going to go ahead and square the x minus 1. Now in order to square the x minus 1, really what needs to happen is I need to write it as x minus 1 times x minus 1. That's what squared means, times itself. Do not distribute the squared. If you do that, I'm going to smack you up. I will hunt you down and I will smack you upside the head, and then that's probably about it. So anyway, we'll just go ahead and distribute. We got x squared, x times -1, -1 times x, which would be another, sorry, my x's are disappearing, and -1 times -1, which would be +1, leaving me with x squared minus 2x plus 1. This is covered in our very first unit on algebra skills, so if you need that, you can go look at the video on that as well. All right, so at this point, I'm going to go ahead and put that in. Y equals -2 times x squared minus 2x plus 1. This is still in parentheses because I haven't really distributed the -2 yet. You shouldn't distribute the -2, by the way, because it is exponent first and then the -2. So from there, we'll go ahead and we'll say y equals -2x squared plus 4x minus 2, and then minus another 2. So y equals -2x squared plus 4x minus 4. All right, now we'll go from there. So first thing we want to do is find the axis of symmetry. Axis of symmetry is at x equals -b over 2a. Now you should know already this is going to be flipped upside down and it should be stretched a little bit. Even if you don't know anything else about transformations, you should know what happens with the stuff in front of the x squared. The negative flips it upside down. 2 is going to stretch it vertically, so it'll look a little bit taller, skinnier, you know, whatever else you may say. All right, so we're going to go -4, because b is 4, all over 2 times a, which was -2. So I got -4 divided by -4, which gives me 1. So again, my axis of symmetry will be at 1. That's just coincidence. It's not always at 1 any more than it's always at 0. You take that 1, you put it back into the equation. I'm going to put it back into the original equation. I think it's always safer to put it back into the original. So I go y equals -2 times 1 minus 1 squared minus 2. Y equals -2 times 0. That will be 0, of course, and so I end up with -2, which, yeah, you probably should have known that already, but I'm not going to go into that right now. Okay, so we got our vertex at 1, -2. Next, we should go for the y-intercept. I usually do the y-intercept before the x-intercept because the y-intercept always exists. The x-intercept doesn't have to. Okay, so the y-intercept will be at x equals 0, so I put 0 in for x, and so I got -2 times 0 minus 1 squared minus 2, -2 times -1 squared, and that would be negative 2 times 1, because negative 1 times negative 1 is positive 1. Negative 2 minus 2 is not 0, it is negative 4. So that will be that right there, and then reflected on the other side. Now, you should already know that you're not going to get an x-intercept, right? Because if this is the vertex and it's pointing downwards, you can see that the graph's just going to kind of go like this. There's no reason then for you to look for the x-intercepts. I'm going to go ahead and show you that if I do, it's not going to work. So the way I'm going to do that is by using the discriminant, which is b squared minus 4ac. b will be 4, so that'll be 4 squared minus 4 times a, which was negative 2, times c, which is negative 4. Now note that I'm using this equation because in order to do the discriminant, I need a, b, and c. So I can't go back to the original. That's the only reason I'm not going back to the original here. And if I do my work, I end up with 16 minus 4 times 2. Now let's go negative 4 times negative 2 is positive 8 times negative 4 is negative 32, which gives me a negative 16. And remember, when the discriminant is negative, that means that there are no solutions. So since I'm finding the solutions for the x-intercept, that means there are no x-intercepts. All right, so we've confirmed that. I would like to have just one more point. It's just nice to have one more point. So I'm going to go ahead and put in 3 for x and just put in another number. I've got all the special points that I could possibly get. So again, back to the original. Y equals negative 2 times 3 minus 1 squared minus 2. That will give me negative 2 times 2 squared minus 2, and then negative 2, well, I guess it would be 2 squared first, so negative 2 times 4 minus 2, so negative 8 minus 2, which is negative 10. So when x was 3, y was equal to negative 10, because this is y equals, all of that. Okay, so I go to 3, negative 10, I put that point down, reflected, it's 2 spaces away, so reflected on the other side. Now I can draw my graph. Now remember, this is the point where we have to start considering the fact that it's an inequality. So I go back, I look at my inequality, which is right here. Notice that it's less than or equal to. Alright, so if it's less than or equal to, that means that it should be a solid line, because equal to is represented by the line itself. So unlike in the last one, remember the last one we dashed, and we dashed it because it was just greater than. So here we go. Nice solid line to say that the points on this line should be included in my solution. All right, and then I need to find out which side to shade, because knowing that it's an inequality, I'm going to have a whole range of answers, a whole bunch of possibilities. So I put in a number. Again, my favorite is 0, 0, just because it's the easiest. So I go 0 is less than or equal to, so here's the point that I'm testing right here, 0, 0. Negative 2 times 0 minus 1 squared minus 2. So this, of course, will be negative 1, so it'll be negative 2 times negative 1 squared minus 2. I will square the negative 1. Negative 2 times 1 minus 2 will give me negative 4. So I end up with 0 is less than or equal to negative 4, which is not a true statement. Negative 4 is definitely less than 0. And so in that case, that's not working. I'm going to have to say shade the other side. And so here's my answers. Now, hopefully you've noticed in the last 2 questions, if we look at the previous one, when it was y is greater than, we had the greater y values. You can look at the y values here on the y-axis. The bigger numbers are up top, the smaller numbers are down below. So if y is greater than, then we generally shade up. I would always go back to substituting in a point, because if you have to do any algebraic manipulation and you forget to flip the sign or something like that, you could actually make a mistake. But if I substitute back into the original equation, the original inequality, you should always end up with the right answer. Okay. Now here, same thing. Y is less than or equal to. Notice that I'm shading the y values that are lesser. The negative y values are all going to be included here, and the greater would be on the outside. Okay. Now I do want to point out that this would have been 10 times easier had you used transformations. Oh, transformations. Okay, so a quadratic, remember, should be at 0, 0, 1, 1, 2, 4, right? Possibly 3, 9. What happens here? Well, I've got a x minus 1, which is horizontal. So that means it needs to shift 1 to the right. Okay, which will put it here. 1 to the right. All those points are shifting 1 over to the right. Alright, so there's my new graph right here. Alright, then I've got two things happening not directly to the x. It's being multiplied by a negative 2, and it's subtracting 2. Now, because it's not directly to the x, that means it will affect y. It'll affect y exactly in the way that we expect. Well, if it's a negative, I expect it to flip it upside down. And because it's a 2, I expect everything to be multiplied by 2. So I'm going to take each of these values, 4, multiply it by negative 2, which will give me negative 8. This one right here, 1, which multiplied by negative 2 will give me negative 2. 0, which multiplied by negative 2 will still be 0, of course. And then 1 right here, which multiplied by negative 2 will give me negative 2 still. And, oh, come on. Then 4 again, multiplied by negative 2 will give me negative 8. Now, I did the multiplication first because according to PEMDAS, and I'm following PEMDAS because anything done to y is done in the order that it should be. Nothing's backwards. So I did the multiplication first. Now I subtract 2. I expect that subtract 2 means move it down 2 spaces, and you'll notice that that will put my points right on the place where we had graphed them. And so we would still get exactly the same graph, but I didn't have to do any of this. The only thing I had to do was at the end I would still have to test that point, make sure that it actually works or doesn't work in the equation, inequality, sorry, so that I would know which side of the line to shade on. All right, so that's it. That's your last example. You should be able to go to work now. All right, good luck.